Oh, started recording.
And what's happening now?
No, don't worry. It's fine.
Okay, I got something on my screen here.
Don't pay attention.
Okay, I'll leave it alone.
Yeah.
Okay, so science says that the universe is 13.8 billion years old, and Torah says it's 5782 years old from the sixth day of creation. In Psalm 19, verse 2, King David writes that the heavens declare that the glory of God, and the skies proclaim the work of his hands. So the Torah is saying here that it's not troubled by the theories of science. That at any one time, eventually science will become round to confirm that the Torah is true. It is also saying that by investigating the universe and by investigating scientific reasoning, humans will be able to reconcile their findings with the Torah. However, admitting it sometimes might be a problem. So until the 1950s, I want to give an example of that. So until the 1950s, cosmologists were convinced that the universe always existed, unchanged. This was labeled the steady state theory. They thought that the universe looks the same this year as it did last year. It looks basically the same if you look to the north or to the south. But by contrast, the Torah states that there was a beginning in Genesis 1:1. In the last 100 years, science has done a complete about-face, but did it kicking and screaming all the way. So the first nail in the coffin was hammered in by Edwin Hubble in the 1920s, who studied the heavens using that 100-inch telescope on Mount Wilson in California. He measured the distance to many observable objects and then measured the wavelength of light coming from these stars and discovered that these objects were moving away from the Earth, and the further away the object was, the faster it was moving away. He was the first to propose that the universe is expanding, but expanding from what? Many scientists did not accept his findings, probably because it made them feel uncomfortable. Over the next 20 years, scientists like Einstein, Eddington, and Hoyle tried in vain to explain Hubble's results with various proposals that did not acknowledge a beginning, but they were all eventually dismissed as fundamentally flawed. The second nail in the steady state theory coffin was the discovery of quasars in the early 1950s by a number of cosmologists. Quasars are strange anomalous objects that defied explanation at the time. Quasars were only found more than 10 billion light years away and never any closer in time, which strongly suggests that there are no quasars anymore and that they were formed in the early universe. Their purpose completed, then disappeared. Disproving the steady state theory, we only see that the light that came from these objects today because it's taken 10 billion years for the light to reach us. Finally, Arno Penzias and Robert Wilson, who were working at the Bell Telephone Labs in New Jersey in 1964, detected the microwave background radiation that was predicted by George Gamow 20 years earlier. And this radiation was the remnants of the so-called Big Bang, the moment of creation of the universe. Penzias and Wilson were awarded the Nobel Prize for Physics, and at that point, the majority of scientists abandoned the steady state theory and accepted the idea of a beginning. Incredibly, in 1993, Fred Hoyle, despite the overwhelming acceptance of the Big Bang theory, published a new version of the steady state theory. This goes to illustrate just how uncomfortable scientists were to accept a beginning, because it means that there is a creator and therefore a moral code, and that subjugates our lives. So that's one contradiction of science and Torah that was resolved. Rabbi?
Right. So how that so how do we deal with the age of the universe? I mean, that seems to be a.
Well, before we move on, was there any questions regarding what I just said here?
Yeah, in fact, I think that Maimonides writes that Aristotle, that Maimonides said that the natural intelligence tells us that the world always existed, and it says in the steady state theory, and that he based it on Aristotle, who was like the big guy at those days.
Right, Copernicus also, yeah.
Right, and that was the accepted theory that was around in those days. Even Maimonides accepted that as the norm, and he said that the creation is against the natural thinking.
Yeah. Some of the things like that, the background radiation is a little hard to understand, and maybe I'll try and it'll become a little bit more clearer as we go through the material here. Yeah, okay, so let's move on. We're going through it rather quickly.
If anyone has any questions, you want to add something, you can put it onto the chat box, or you could even break in if you like. If you feel it's
turn the microphones on first.
Yeah. If you feel it's something that's beneficial for the subject matter, not a sidetrack,
I just wrote in the chat box about a book on this topic that might be of interest to everyone as well.
Okay.
By Rabbi Natan Slifkin.
Yeah, he's very good.
He wrote a book called The Challenge of Creation, Judaism's Encounter with Science, Cosmology, and Evolution. And he also has a museum in Bet Shemesh called the Biblical Museum of Natural History.
The zoo. He's called the zoo rabbi. Yeah.
Sorry?
He's called the zoo rabbi, the zoologist. He's
Yeah, that's something that we will hopefully we'll get to next time, another, say, a month's time.
Excuse me, can I ask a question? I understand you saying that there has to be a beginning, and that we accept that the steady state theory is not a valid theory, and it's been now superseded by the fact that there was some form of creation. Where I have a problem is you made a statement, Michael, where you said that this proves, because there was a creation point, that there is therefore morality and some kind of law, I guess, related to the behavior of.
Right. So, but what I'm saying here is that if there was a beginning, then there was somebody some entity that made it begin, and that we're claiming that entity is God, and what comes with God is a code of life, which subjugates our lives, and that's what a lot of the scientists didn't want to happen. They didn't want to be subjugated. Does that answer your question?
We'll park it on the back burner for a moment. We'll get back.
It's an ongoing conversation, Michael.
Right.
Michael. But maybe you could lead us into like the whole idea of, the creation of in the Bible. It's very, very clear. God created the world in 6 days, and then there was Adam and Eve, and we're counting now 5,782 years from then. How does a thinking person reconcile it? You're saying there are stars that didn't exist for 13 billion years, right? So how do we
I'm saying that there are stars that used to exist 13 billion years ago, but don't exist any longer.
Right. So that's very strong proof that there was a world back then.
Right.
So how do we tie that in with the Torah?
Right. Okay. So I'll move on to my next part of the talk. So we want to understand how we resolve the 13.8 billion years and the 5782 years that the Torah says that the world's been around. To answer this, I'll use a number of scientific luminaries and devout Torah scholars to propose that the 6 days mentioned in Genesis chapter 1, verse 1 to verse 31 And the 5,782 years are based on 2 different timescales of measurements. So to our subscribers, I ask you to listen carefully, as there is a number of critical parts to this, and I'll be giving an oral test afterwards.
Okay.
Okay, so go ahead.
I hope that was a joke.
Well, maybe.
The answer is B. The answer is B.
Okay, so first we must recall that we human beings, Jews anyway, measure the world 5,782 years from the creation of man, and not the first day of creation. We celebrate Rosh Hashanah as the first day of the year to remember the most fundamental date in our history, and also the ultimate pinnacle date in Hashem's purpose for his creation, which is man. And maybe I should interject here to say that when I say man, I mean women as well. Okay, so we have to be very careful here.
PC.
Yeah, and also yeah, when I say he, it means he or she or any of the other 10,000 possibilities that the Canadian government have voiced on us. Okay, so there's no dispute from a religious or secular point of view that this counting is correct, as the Torah gives a cumulative timeline from the birth of Adam through biblical history, and then using contemporary history to the current day. It doesn't need a quantum computer just for some perseverance. Just needs some perseverance and an Excel spreadsheet or a calculator to work out that number 5782 is correct. And so the challenging part is understanding the 6 days. So you can talk about errors in carbon-14 dating, or perhaps they didn't weigh things correctly, or the oxygen content in the atmosphere was different back then. There's no way you're going to squeeze 13 billion years into 6 days. So we have a bit of a problem. The Torah goes into some detail of what happened on each of those days in Genesis. At the end of each day, the Torah says it was evening and morning a second day, or a third day, all the way to the 6th day, Yom HaShishi. But it does not say Yom Rishon, the first day. Instead, it says Vayhi Erev Vayhi Voker, Yom Echad. There was evening and there was morning one day. The Torah here is defining what a day is. It's a period of darkness followed by some kind of illumination, some light. Nachmanides asked, why does the form of the day number change from the absolute 1 to the comparative 2nd, 3rd, etc.? And his answer is the Torah writes day 1 on that first day because there was not a second day. And to write first, it means it must be a comparative to the second day. So it would seem that the biblical perspective of time for the 6 days of Genesis is from day 1, looking forward. I'll get back to that, this line of thought in a moment. Right now, I want to talk about how the Torah decrees how man was to tell time. We humans use the sun and the moon and the rotation of the earth to keep time. But the sun and the moon was created on the 4th day, not the 1st day. So it was interesting. So what timepiece did the Torah use to count the first 3 days? Furthermore, the Torah doesn't stop at the creation of the sun and moon. It goes on to describe the purpose of the sun and the moon. You would have thought that the purpose for the sun was to provide heat and light so that animals, fish, and plants can survive, or the moon so that we can have romantic walks on the beach. But no, it says that they are to separate between day and night and for signs and for festivals. So perhaps God is saying, I have my own definition of time, but my days are so long that a human being would not survive long enough to see more than 1 day, and therefore never celebrate any of my festivals. Further proof that God's timepiece was different than that of humans, it's found in Psalm 90, verse 4, where Moses is praying to God and he says, For 1,000 years in your sight are like yesterday when it is past, and like a watch in the night. In this one verse, we read about 3 perspectives of time: 1,000 years, a day, and a watch in the night. In our universe, perspective is everything when determining the apparent passage of time. How can we use science to quantify how we can understand how 13.8 billion human years can be explained by the Torah as 6 days in God's eyes? The following explanation is the work of Dr. Gerald Schroeder, who earned his PhD in nuclear physics and Earth and planetary science from MIT, and has been a consultant for the US and worldwide governments. He published 3 books on this topic and is currently the senior lecturer at Asia Torah in Jerusalem. So he starts off with citing Albert Einstein, who in 1915 published a paper on what he called general relativity. And in it, he proposed that the force of gravity of massive objects like the sun affects the measurement of time. And this was confirmed by Eddington in 1919 when he detected gravitational lensing during a lunar eclipse of the sun. So what happened was that when the moon passes in front of the sun is blocked out, and all you see is a corona of the sun. But you're able to see the stars behind the sun, close to where the sun would have been. But you wouldn't have seen this if the sun was not with a moon in front of it. You wouldn't have seen this. So if you're able to then see these stars behind the sun, you can then measure the angle or the relative the position of these stars. And then when the sun was no longer there, and you look at the position of these stars, you'd see that they had shifted slightly. And Eddington and Einstein, this basically confirmed Einstein's paper on general relativity, that the gravity of the sun had moved the light or bent the light coming from these stars that were behind it. And the distance that was measured by Eddington in 1919 confirmed what Einstein's mathematical predictions. So I want to use an example to explain this effect without getting into mathematical equations. So in 2013, NASA worked out the age of the universe. It was 13.8 billion years old, according to their measurements. I think they sent up a number of satellites to work this out. It's not really important how they did this to our discussion. Obviously, NASA did this measurement on planet Earth with planet Earth's gravity and planet Earth's current orbital speed around the sun. If the measurement was done, say, on the surface of Jupiter, where the gravity is substantially larger, then NASA would have measured the age of the universe as 200 million years less than the 13.8 billion years that we measure it. And if it was done on the surface of the sun, if that was even possible, it would have been 800 million years less. So the measurement of time is greatly affected by gravity. In fact, this phenomenon is called the time dilation, and that was what was proposed by Einstein in general relativity. And the larger the force of gravity, the smaller the age measurement. So let's take this effect to its ultimate limit. Let's try and calculate the time dilation just a few moments after the event of creation of the universe itself, when stable matter was first formed and all matter was compressed into a small volume about the size of a peppercorn. And around that time when Hashem said, "Let there be light." Gravity would have been enormous compared to that on the earth today, and probably on the earth when Adam was created. Dr. Schroeder needed some number as a factor to use in his time dilation calculation to work out what the age of the universe would have been calculated given the events and the rate of expansion and the gravitational changes of the universe in the first moments up until the creation of Adam. At the end of in day 6. Fortunately, these calculations had already been done by a cosmologist called Professor Jim Peebles in 1993 at Princeton University in California. Jim Peebles is a Canadian physicist and a cosmologist who was born in Winnipeg, Manitoba, and is a well-known author in cosmology. And among other awards, he won the Nobel Prize in Physics in 2019. Sorry, my voice is a bit of a challenge.
Perfect, Michael.
Okay. Schroeder was looking for a factor that was able to, so that he was able to calculate what the order of, so he could calculate what the time dilation was back if we worked out back on that that particular time. Peebles had calculated this factor to be 1 trillion. I'll explain what that is in a minute. There's an error, obviously, in that calculation of about 10%. So what does that mean for us? How can we use this information to help? Does it help us in resolving the science Torah age of the universe conflict? So given this factor, we can work out a scenario that will help us in understanding this conflict. Can we indeed work out God's time space? Is it valid science? Let's see. So here's the scenario. If somehow a fictitious someone who existed a few moments after the Big Bang, and he has a way of sending an email message out into the unknown that says, I'm sending you a message every second. This is message number 1. And he continues sending out these numbered messages every second in his time frame. So now here on Earth, we receive message number 1. Would we in fact receive message number 2 in 1 second's time? The answer is no. In fact, we would have to wait approximately 1 trillion seconds. That's the number that we were referring to before, the Peebles factor, or 32,000 years before receiving message number 2, because that's the stretching effect of the time expansion. Time expansion is the opposite of the time dilation, because we're going from the other point of view. Because at this time, we're going from a point in time when the gravitation was huge to a gravitation in which, as we know it here today on the Earth. So Torah talks about 6 days. How would we see those 6 days from this new perspective, God's perspective? 6 days would be stretched out to 6 trillion days. What would that be in years? So we divide 6 trillion days by 365, and it comes out to be about 16 billion years. So now compare that with our current estimation of the age of the universe of 13.8 billion years. And now we have much closer agreement. Back to you, Rabbi.
Oh, wow, man, I'm blown away. Okay, like it's like the kid comes home from school and the kid has a 98. So the mother says, you had a 98 score. What happened to the other 2 points? Right?
Yeah.
So more or less the kid's done great, but you're still not there. You have 16 billion years as opposed to 13.8 you said before.
Yeah, but what I said was that his Peebles factor was plus or minus 10%.
Ah, okay. So what's 10%?
His mathematics, it has a lot of errors in it, but
it's a rounding error.
Yeah, right.
A rounding error, right?
Rounded off to the nearest billion years.
Right.
That's actually, it's incredible that they figured that out. It's very, very close.
Yeah. Yeah.
But wouldn't it also change every day?
Yes, it does, and that's why it wasn't a simple matter of working out what the size of the universe was, and then taking it as a factor of how big is the universe now and how big was the universe then, and then working out the factor. Yeah, of course, he had to do a fairly complicated a bit of calculus to determine exactly what that would be, because obviously as we progress in time, then that dilation or that stretching effect gets weaker and weaker as we get further through the time. So he had to work out what that would be, but he came up with this value of 1 trillion.
Michael, I have a problem with this calculation of yours, and let me tell you what it is. You see, you can't measure things in terms of portions of a 24-hour cycle, which is what we're talking about when we talk about a second, because that's calculated based on the spin of the Earth and light and dark and et cetera, et cetera. What I think one has to do is have a different unit of measurement. You've got to be talking in terms of something like the wavelength of an oscillating pair of electrons, or something which is going to be a universally accurate measurement of time, irrespective of whether it's here on this Earth or on Uranus or 100 billion miles from here. I think
that would be nice, but it doesn't exist.
Well, of course,
so even if you use an atomic clock, for instance, which is atomic clocks are based on using a cesium crystal,
right,
and looking at its vibrations, and it's a very accurate way of measuring time, and we translate the number of vibrations of this cesium crystal into a second and into our seconds, and then we use that to measure time. But it only works in our frame of reference. If we move it to Uranus, as you said, it would be a different frame of reference. Time would be measured in Uranus time, not in Earth time. And if you move it back to the point of the beginning of the universe, that same crystal would also be in the frame of reference at that particular time. This in fact was Einstein's special relativity theory, which he came out with in 1905, with that time was relative based on where you're measuring it. So it doesn't matter what instrument you're using to measure it, it will always change. Does that answer your question?
Well, again, let's hold this one on the back burner. There's a lot of things to discuss here tonight. You've taken on one hell of a subject, Michael.
Was it? We got time, so ask questions.
Okay.
Hey, Michael, you have some more. Go ahead.
Can I just ask,
Kathy?
So did the measure of time or recreation changed after the fourth day? So was the first 4 days before the sun and the moon was different, and then did something change after? Or is it the equal?
On the fourth day, it says God created the sun and the moon.
Yeah.
And it says, as I said before, it says that the sun and the moon were created for human beings, it wasn't God's timepiece. It was human beings' timepiece.
Okay.
That's why it says it was for festivals, for events and festivals. So it's we that celebrate the festivals, not God. And as I said, if we use God's timepiece, which with days were billions of years in length, then we would never live long enough to celebrate a festival.
Mhm.
And the Torah goes into festivals. That it was part of God's plan that we celebrate festivals. So we needed a timepiece for us to use to work out when those festivals occurred.
But Kathy, just to take on Kathy's question, you said at the beginning that we start the 57822 from the day of creation of Adam, right?
Right.
From the sixth day of creation, right? So between the fourth day and the sixth day.
No,
right?
okay, I understand what you're saying, but as it was for human beings, means of measuring time,
Right.
it wasn't put into effect until we had a human being.
Okay, right. The tools were created.
Yeah, the tools were created for.
But they were not yet being implemented by anyone, right? Because God continued to count the way He counts, just by the measurements of light or whatever.
Right, right.
Right.
And you can even see on the sixth day, according to our sages, Adam was created on at midday on the sixth day, which in other words will be 75% of the way through the day.
Correct. Yeah.
Right. So he had a quarter of a day to do what he was required to do in that first day. The first day that he was first day in God's timepiece, but I'm not quite sure how we measured it for Adam. But in that quarter of a day, he had 2 children. He named all the animals, and I believe he did a whole bunch of other things as well. So how was he able to do that in that short space of time? Obviously time was a little different back then.
Right, but that would sound like too long. if you're counting in God's, if every day is a few billion a few billion years,
right?
So that means Adam was around for.
Yeah, but it wasn't it's not a linear way of looking at time. In other words, day 1 was much longer than day 2.
Okay, so it kept
day
on.
3 was it gets exponentially less and less and less.
Mm-hmm.
So yeah, so how you would measure that, I'm not quite sure, but I think Schroeder actually goes into how you can resolve that question.
Mm-hmm.
Get his book.
Yeah, right. Brian, you have to mute yourself, Brian, to ask a question. Brian Platts, you have to mute yourself.
Hi, Michael. Very interesting so far. Really enjoying it. It's actually I very often watch stuff like this late at night on YouTube, and very interested in this type of thing. But I have a question which is perhaps a little bit more philosophical. I just pulled up, just to make sure I wasn't getting things wrong, but I pulled up the first 3 or the first few sentences of Bereshit. And I'm wondering why Bereshit wouldn't have started with verse 3 as opposed to verse 1, because verse 1, it talks about the heaven and earth, and mentions earth, which hadn't even been created yet. And yet, perhaps a more correct or more scientific way of writing those first few verses would have been to start with verse 3 and say something like, in the beginning there was absolutely nothing, and God said, let there be light. Does that make some sense?
Can I jump in? Can I jump in for a second, Michael?
Yes, yeah.
Okay,
Michael,
Michael.
let me just interject first of all, and
Okay,
then maybe you can come in afterwards. Okay.
Okay.
The word Bereshit means in the beginning of, not in the beginning. So in other words, creation had already started. It was what he's describing there is creation, what we need to know about creation, not necessarily what God needs to know about creation. It was a ongoing process, and you're saying that verse 3 is let there be light. So I'm not quite sure what it is you're.
Well, because it sort of translates into the Big Bang in a way. Because once the bang had happened, now you have light.
Yeah, you do, but the light was turned off. even according to scientists, the light only came on for a little short time, a period of time. Then there was
There was
darkness.
no light right away.
Sorry.
Yes, there was no light after the Big Bang. There was a dark period of time, millions of years.
Yeah,
The light
it's called the inflation.
inflation, exactly.
Right. So there was light. There was an initial light, but then you had a period of darkness.
Oh, okay, so you've answered that question then. That makes some sense. Yes.
And then light was created. So what that light was, the beginning of that maybe the rabbi can elaborate on.
But so really the first three sentences really is simply setting the scene for our benefit.
Rabbi, that's more a question for you.
Oh, yeah, Michael, I was just saying, so let there be light can either be the first light, the very first flash of light, or it could be the light which came way later,
Right.
After that period, which was called, I don't remember what you called it, the inflation or whatever, right?
Yeah, the inflation, yeah.
Right. But just on a simplistic level, from a more linguistic level, what Michael said before was that you don't read it in the beginning, God created the heavens and earth, but you read it in the beginning of the creation of heaven and earth, when everything was chaotic, blah, blah, blah.
Okay.
And
Yes.
God said, let there be light. So that's the first thing that happens, is let there be light. So it's not it's not telling you what happened in the beginning. It's telling you that in the beginning, it's like a preposition. In the beginning of heaven and earth, when the earth was in a state of chaos, and God said, the first thing was, God said, let there be light. So that could refer even to the first light.
Right. Yes, of course.
You translate it that way.
Yeah. But
Is
that's
that
always
the
been the trouble
primordial?
all along with translation, where very important nuances are missed.
Yeah, well, you have to thank King James for that.
Yeah,
that's right.
That's true. Yeah.
We can also thank Nachmanides and Rashi for illuminating it.
Right, for sure. Okay. There's some questions over here. Is that the primordial light? Michael, you see the question in the chat box.
Can
you see it?
Oh yeah, I see it. Is it the primordial light? I don't know what the primordial light is. Is that the light of it, what they call the inflation light? I've got a I don't know if you can all see this. I don't have it on the computer, but can you see this?
Mike, the oldest light in the universe is the primordial light, if memory serves.
Right. This diagram was created by NASA, and on your left-hand side is the beginning, is creation, and you can see that there's a thing called the inflation, and there's light, and then there's a darkness.
We see it,
yeah, and that's NASA. That's NASA telling us that there was light, there was darkness, and then there was another more light.
Michael,
light, we don't know.
Yeah, I just looked up primordial light, and they're saying that it's the name given to the oldest light when photons first started to emit light, which is actually 13.7 billion years, not 13.8. So you're already, a little way along the time scale.
Yeah, exactly. You're right. Photons have to be separated from the other particles. so when the universe was first created, it says that it was tohu and vohu. It was complete chaos. In other words, the particles that were around that time could have been any number of particles. It could have been well, it certainly wasn't protons and neutrons. It was the quarks that were probably made up of, that make up the protons and neutrons. Protons and neutrons happen much later. Once you have protons and neutrons, then photons can separate out from that, and then also electrons were formed as well. So and that's when you start to get real matter. You have atoms, hydrogen, helium, basically at that particular time.
Right.
Michael, I want to ask you something, Michael. You know, NASA recently launched the James Webb Telescope.
Right.
Why all the interest in this quest, and what could the telescope achieve that would support Torah or vice versa?
Yeah. Okay. So let me talk about the James Webb telescope. It's just it was launched about a month ago, and it just recently reached. It's been deployed completely. It's been a great success up until now, and it's reached its point where it's going to do all its work. It's called the L2 point. Now, for the last 30 years, we've been relying on a number of telescopes, but mainly the Hubble telescope, named after Hubble. And the Hubble telescope only works in visible light. The James Webb telescope works in mainly in the infrared part of the spectrum. Now, for those who are not familiar with the spectrum of light, infrared is longer wavelength than visible light. You have, sorry, my voice is going. You have infrared, you have visible light, then you have ultraviolet. If you go up the spectrum in frequency, but we need to look at. But the James Webb telescope has been designed to look at objects far, far away than the Hubble telescope was able to see. And in order for us to see these objects, we have to be looking at the infrared. The reason being is that if the universe, as we've discussed, the universe is expanding. And the further away you look, the faster these objects are moving away from us. So if an object is moving faster away from us, light coming from that object is going to be in the infrared. And might need to explain that, but you might be familiar with what's called the Doppler effect. If you're in your car or you're out on the street and you hear an ambulance or a fire engine coming towards you, and then it goes past you, that the frequency, the note of that siren goes from a higher frequency to a lower frequency. You hear it, you hear the difference in frequency. The same thing occurs for light, in that light always travels at the speed of light. It doesn't matter whether it's coming towards you or coming away from you. It always the same speed. But if it's moving away from you, it's light's coming at you at a lower, at a much higher wavelength and a lower frequency. So in order for the telescope to see objects that are far away, and it wants to look at objects that were created or were around 100 million years after creation, it needs to be looking at the infrared. And because the infrared is something that is generated by heat, everything we see in a normal life, in a normal day, it generates infrared. We just don't see it. We can feel it because it's heat. So the James Webb Telescope has been designed so that it has this shield that shields itself away, the telescope away from any light coming from the sun and the earth, and it operates in a very, very cold environment, minus 223 degrees Celsius. And in order and because of that, it's able to detect infrared light coming from these far distant objects that don't exist anymore, but they are the remnant light from the early objects of the universe. So what the James Webb Telescope is really doing is looking back in time to 100 million years after the universe was formed, and looking at to see what these objects were. These were objects that were predate galaxies and stars. What do they look like? What were their physical makeup? So that's what the James Webb Telescope has been designed to do. I hope that hasn't confused people.
Find God. You think it can find God for us?
Was he created on the first day of creation?
Yeah. So is this good news for the Jews or bad news?
What would be bad news?
I know. What's it going to prove for us?
Well, it's going to be another nail in the coffin from the steady state.
So it's going to reinforce the
right.
Big Bang concept.
The same thing as a quasar. Quasars don't exist today. Quasars only existed 10 billion years ago.
Right.
There were objects that created light, such intense light.
Mm-hmm. So this is going beyond the quasars.
Yeah, this is going back even further back from quasars. So when the Hubble started, when the Hubble was around, well, it's still around, but at some point in time in the Hubble's work, it looked at an area of space that was in all intents and purposes was void of any stars. When it looked deep into that point, it saw faint objects, and these are the objects that the James Webb Telescope is going to be looking at.
Incredible.
It's also going to look at other things like exoplanets, hoping to find life on in other galaxies or closer solar systems. Richard, you look like you've got a question.
Yeah, it does.
Who, me?
Yeah.
Yeah, you.
I'll always have a question. So and it's not connected to what you were just talking about, but when we talk about Adam, and as in the Torah is the first human being, but are we necessarily convinced that Adam was the first human being, or the first human being created in the image of God?
Okay, that's something I want to talk about in another lecture.
Yeah, that's the evolution class.
Okay.
Mhm.
We're doing that's another class. It's the evolution class, man.
Yeah, we're talking about the age of the universe here. But it's a good question.
Anybody else have some questions? You're all welcome. Milton, you have to unplug yourself.
Can you hear me now?
Yeah, go ahead.
Now you can hear me, right?
Happy birthday, Milton.
Thank you so much.
Oh, happy birthday.
Happy birthday.
Thank you. Don't ask me my age because I lie,
13.8 billion years.
I'm 39, you know, like Jack Benny.
It's all relative.
Yeah, right.
That's right. Well, I'm very immature for my age, that's for sure.
Right.
But the question, it's a question that we're talking about something though, so distant from the needs of our present day concerns. That's troubling me. All the billions of dollars that are spent for this exploration of space and getting to the moon or to the Mars or wherever they want to go is so unnecessary in relation to the needs of our present day causes that have to be subsidized with that kind of money that we have. That's my question. This seems to be, this is anti-Torah.
Anti?
Torah.
Oh. Well, I don't know how I can answer that question. I would just suggest you put your name forward and become a member of parliament. And then you can...
The James Webb telescope only cost $10 billion though. Milton, it was very inexpensive.
Yeah, but
there are a lot of.
But I was thinking if they need a place that's 200, what is how many 200 degrees Celsius below zero?
Minus 223
Negative
degrees.
223.
Right, so why don't they just build it in Toronto?
But not that cold.
Yeah.
And, you know, every dollar that's spent on space exploration and all of these things, Milton, and I hear what you're saying, all of those dollars go to people. It's up to those people to then use those dollars for good, to get the charity to help others.
If we didn't have the space, program, even the one where we went to the moon, we wouldn't have a lot of the things that we have today.
Yeah.
And also think of all the jobs and the spin-offs that it
microwave.
creates thousands upon thousands of jobs for people's livelihoods. Drives the economy.
Yeah.
When Kennedy said in 1960, whatever it was, we're going to send a man to the moon and bring him back safely, he created hundreds of thousands of jobs in the US and other countries, mostly in the US. So, you know, there's a real economic spillover from this thirst for knowledge and this striving to understand the universe and where we fit in it.
Right. In 1961, when he said that, we had transistors. We didn't have integrated circuits. We didn't have ways of controlling rockets. We had no way of knowing how what we needed to put in a rocket at that point in time. Yeah, they create jobs, and those jobs required people with certain degrees in physics and electronics, and we needed that for many other disciplines.
A lot of technology is protecting Israel today.
Yeah.
Think about that, Milton.
A lot of the technology comes from.
That may be a good point. I agree with you on that.
I knew you'd like that one.
But weaponry has been the catalyst for so much major developments that are sometimes useful for human rights and human needs. But going to the moon or going to some other far distant planet doesn't make too much sense to me. I don't think I know why.
But that's the way knowledge works. You expand yourself outward, and then you go in a circle and you come all the way back inward. That's the way everything works. You know, it's so you expand your horizons of the world, and then you have a better understanding of yourself.
It's all about the byproducts.
Well, why don't we take this back a step and say, when Columbus set out, it cost a fortune, and he went and discovered America. But, you know, we're now at the next level of this. We're sending people out into space, which is, we're just on the very fringe of it. What's going to really happen here is that we're going to send out artificial intelligence devices, which are going to go and inhabit other worlds, ultimately. And it's a natural development that's going to have to take place.
Yeah, we can. I mean, we can only go within our own solar system. We can't go out any further than that.
No, we can't.
Sorry.
I know we can't. Not as individuals. but we can send
To
out
get, to
artificial
get to the nearest star, to us, which is Proxima Centauri.
Yeah, it's 4.8 billion light years, or 4.8.
Right, it'll take
light years.
81,000 years.
Yeah, sure. So
Chevre,
eventually,
We better
eventually
start today.
guys, there's a lot of time left. So I just want to say thank you to everybody for coming. This is just the start. Whoever really enjoyed this, let's have a round of applause for Michael. Michael, beautiful job. I'm talking about Michael Shear, but also Michael Ruskin and all the other Michaels. But Michael, really, you really blew us out of the park, and really made a home run, and it's really beautiful, and we really enjoyed the Torah and the science and how it comes together. It was quite. We've had a lot of different people speak on the subjects many times before, and they were out there. I don't know. They were on another planet. But your stuff was logical. It was understandable. It was acceptable. Not exact. We might be 1 billion years off, but at least we're in the ballpark. So, Michael, thank you very much. We look forward. We're going to be doing a few more classes. We'll try to do this like once a month. We'll have one on evolution, one on cosmology, one on numerous other scientific subjects. So, if any of you guys are interested in that, raise your hand. I mean, I'm interested in anyone else. Once a month, yeah. Okay, so I think we'll do it once a month, Michael.
Yeah,
And
Rabbi, I'd like to
just-
thank you for setting this up. This is terrific. Really enjoyed it.
Rabbi, just a quick point. I don't know if you've taken a poll or not, but now that COVID is kind of getting better and things are subsiding a little, is there a possibility to do this type of thing in person?
then there's no technology.
Hate to put you on the spot, but
we could at some point we'll go hybrid. You know what hybrid is? We have
that's
people
good. Yeah.
together, and also so we want to facilitate. But I find the hybrid sometimes gets a little bit. The speaker doesn't know to which crowd they're speaking to, so it becomes a little complicated. Meanwhile, it's staying on Zoom. Rabbi Zoom is going to have us for a while, and we'll play it by ear. How do you like that?
Yeah.
I quite like this way. This is a very comfortable way to
Michael
do
likes it. He can sit in his house and speak.
it. Right.
Nobody has to go out in the cold weather. We'll do it. In May, we'll do it in person.
Yeah, that's a good idea.
Hey, thank you very, very much, Michael. Beautiful
Thank
class.
you, Michael. It's great. Terrific. Thank you.
Study a lot of science.
Thank you again, Rabbi. That's terrific.
Okay. All the best. Thank you all.
Thank you. Bye.
Bye.
Bye. Thank you so much.
Thank you, Rabbi. Thank you, Michael.
Bye. Bye.